in the control circuit of the car, key anti-shake technology, and engine speed signal processing all involve digital circuits. Flip-flop is a key component in automotive digital circuits. A flip-flop has a memory function which can be used to store binary information according to different logical functions. Flip-flops can be divided into RS flip-flop, JK flip-flop, D flip-flop, and T flip-flop. In this class, we will introduce the circuit composition, working principle, and logic function of basic RS flip-flop. First, let's learn about the structure of the basic RS flip-flop. The basic RS flip-flop is a basic component of every complex gates. It can be composed of two Joker-S or two NOR gates crossed to form. Let's take an RS flip-flop composed of two navigation. As an example, the horizontal bar above the letters R and S represents active low and the horizontal bar is read as none. Normally, the two output terminals should be in an opposite state. The flip-flop has two stable states. When the output terminal Q is equal to E and Q bar equals ln, the trigger is in the one state and Q equals 0. When Q9 等于 0, the trigger is in the one state. The stage before the input signal X is called the current state Qn. The state after the input signal is called the next state Qn plus E. So how does the basic RS flip-flop work? Next, let's analyze its working principle. When the flip-flop line state Qn equals E, RR non equal to ln and S non is equal to E. The left and NOT gates are input is 0. Output C. Both inputs of the navigate on the right are E. Or E output ln. Then the next state of the flip-flopper is Qm plus E 等于0 and the Q non n plus 1 equal to E. The state of the flip-flop changes from E to 0, achieving the 0 in function. When the current state of the flip-flop Qn is 0, when RR non equal to ln and S non T equal to E, the left navigate C ln output E, and both inputs of the navigate on the right are E, or E output ln. The next state of the flip-flop is Qm plus E 等于0, R non is equal to 0. The flip-flop state remains unchanged to achieve the holding function. From this, we can conclude that the two AND gates of the basic RS flip-flop are combined by feedback lines. As long as the two input states are different and the input R is equal to E, no matter what the output state is, the next state is always ln. Therefore, R is usually called the clear terminal. When the flip-flop current state Qn equals ln, when R is E and S is 0, the S end of the right navigate is ln. Outputs E and both inputs of the left navigate are 1. Outputs 0. Then the next state of the flip-flop is Qm plus E 等于 E, and Q non n plus 1 equal to ln. The flip-flop state changes from ln to E to realize the set 1 function. When the current state of the flip-flop is Qn equals E, when RR non equal to E and S non is ln, the navigate on the right has a ln output. Both inputs of the navigate on the left are E, or E output ln. The next state of the flip-flop is Qn plus 1 equals 1, Q non n plus 1 equals 0. The flip-flop state remains unchanged to achieve the hold function. From this, we can conclude that as long as the basic RS, the two input states are different, and the input S non equals 0 is active low. No matter what the current state is, the next state is always 1. Therefore, S is usually called the set 1 terminal. When the current state of the flip-flop is Qn equals ling, R0 is 1 and S0 is 1. The left and NOT gates are input is ling. C ling output E. Both inputs of the negative gate on the right are E. Output C. The next state of the flip-flop is Qm plus E 等于0 and Q0 n plus 1 equal to E. The flip-flop state remains and implement the hold function. When the current state of the flip-flop is Qm equals E, when R0 equals 1, S0 equals 1, both inputs of the NAND gate on the left are E, or 1 output 0. The right NAND gate C ling output E. Then the next state of the flip-flop is Qn plus E equals 1. And Q0 n plus 1 equal to ling. The flip-flop state remains unchanged. It realizes the holding function. From this we can conclude that when the two inputs of the basic RS flip-flop are the same, are both E, they are both in an invalid state. The output will not change, and it continues to maintain its original state. Therefore, when both input terminals are high, the flip-flop plays a holding function. When the current state of the flip-flopper is Qn equals ling and R0 equals ling and S bar is ling, the left and NOT gates are and is ling. C ling output E at the right and NOT gates S terminal is 0. Output C. The next state of the flip-flop is Qm plus E 等于 E, and Qm plus E is equal to E. The two non-complementary output terminals of have the same logic confusion. Obviously, under the normal working condition, is not allowed. Therefore, when the two input states of the basic RS flip-flop are both ling, they are both active. At this time, the non-complementary outputs cannot select instruction and largely confusion because we call the state where both inputs are ling. It's called a forbidden state. This situation is not allowed when the circuit is working. Finally, we combine the truth table. To summarize the logic function of the basic RS flip-flop, whether the current state of the flip-flop is ling or E, the state where both inputs are and S are 0. It's called the forbidden state. When the circuit is working normally, this situation is not allowed to happen. When the input R is ling, and the two input states are different, regardless of the current output state, the next state is always ling. Therefore, when R is ling, it has a clear function. When input S is ling, and the two input states are different, no matter what the output state is, the next state is always E. Therefore, when the S terminal is ling, it has a set 1 function. When both input states are 1, no matter what the output state is, the next state will not change. It has a holding function at this time. Mastering the functions of is the basis for analyzing and understanding automotive. In this class, we learned the structure, working principle, and functions of basic RS flip-flop. It should be noted that its flip-flop has two input terminals RS, which are low-level active low. R is the clear terminal and S is the set 1 terminal. When both RS are E, the state is maintained and the S input is ling. H is not allowed. Now let's use a thought question to check your learning effect. Please observe this table according to the input signals RS and determine the state of the output Q. If Q equals ling, please sit down. If Q equals 1, please stand up.